Welcome to this lesson on comparing and ordering rational numbers. Please be sure you have these notes in front of you so that we can begin our lesson. This lesson has two I can statements. The first I can statement says I can compare decimals and fractions, and the second I can statement says I can order rational numbers. So let's take a look at how we can compare decimals on the left-hand side of our notes. To compare decimals, graph them on a number line. Remember that the smallest numbers are to the left on the number line, and the larger numbers are to the right of the number line. So if we have a number line drawn here, 0 in the middle, we know that all the numbers to the right are large, and as the numbers go to the left, they become smaller. On the right side of our notes, we're going to compare fractions. There are many different ways to compare fractions. One way that we can use is to convert fractions into decimals, and then you can compare the decimals. So let's use these key concepts to solve the following examples. Example 1 is asking us to fill in each blank with the less than, greater than, or equal to symbol to make the statement true. So the first thing we should do is we should use the number line to graph our points. Since they've given us a number line down here, we know that 8/10 go down here. And we also know that negative 1 and 2/10 are on this side of the number line. I know that everything to the right of 0 is positive, which means they have to be larger than the negative numbers. So I know that 8/10 is larger than negative 1.2. So what I can do is I can write my statement as negative 1 and 2/10 is less than 8/10. Or you can write it another way. You can write 8/10 is greater than negative 1 and 2/10. Both answers are correct. Example 2 is asking us to compare negative 1 and 40/100ths with negative 1 and 25/100ths. So what we should do is we should use the number line on the right. They're giving us a vertical number line. And I want to ask myself, what two integers does this number and this number sit between? So I'm going to zoom in on my number line. I know I can zoom in on negative 1 and negative 2 because both numbers are between negative 1 and negative 2. So I'm going to start with negative 1 at the very top because we know that that's closer to 0. And then I have negative 2 down here because it's further from 0, since it's on the negative side. I'm going to go ahead and place tick marks in between my negative 1 and negative 2, which serve as my little stepping stones to get from negative 1 to negative 2. I'm going to count by 2/10 each time. So if I have negative $1 and somebody takes away another 20 cents from me, this next tick mark is going to be at negative $1.20. And then somebody takes another 20 cents from me, I'm going to take negative 1 and 40 cents now. And take another 20 cents away from me, negative $1.60. Another tick mark would be negative $1.80. And if you take another 20 cents away from me, I'm ending up at my integer of negative 2. So now that we have these locations on our number line, it's going to make it easier to graph. Let's go ahead and graph negative 1 and 4/10. It goes right here. So this right here would be negative 1 and 4/10. Now let's go ahead and graph negative 1 and 25/100ths. Would be not on the negative 1.2, but a little over below it, which would be negative 1.25. So now let's go ahead and compare. Let's ask ourselves which number is closer to 0. And we know that negative 1 and 25/100ths is closer to 0. And we know that negative 1 and 40/100ths is farther from 0. So I know that negative 1 and 40/100ths is less than negative 1 and 25/100ths. Or you can write it like this. Negative 1 and 25/100ths is greater than negative 1 and 40/100ths. So let's pause the video, complete these got it problems, and then play it back for some feedback. For example 3, they're asking us to do the same exact thing that we did in the last couple examples. The only difference now is they're giving us fractions. So let's go ahead and convert these fractions into decimals, and you can use the in and out method to do that. So over here in the right hand corner, I'm going to say -3/8, and I'm going to use the in and out method to solve for my decimal. So after using in and out, I converted my fraction into a decimal, so I know that -3/8 is actually equal to -0.375. Let's go ahead and do the same exact thing to -5/16. So after using in and out, I know that -5/16 is equal to -0.312, and it continues to go on. I just kind of stopped after that last place value because it matches up with the place value up here. Alright, so now let's go ahead and graph these decimals on a number line. I'm going to select the integers 0 and -1 because these fractions or these decimals are between 0 and -1. So I'm going to start off with 0 on this side and end up with -1 right here. And what I'm going to do is I'm going to go ahead and count by tenths on the number line. So if I jump one space back here, that's going to be -1/10. Here's -2/10. Here's -3/10. -4/10. And so on. And then I can complete my number line up to -1. Now that I have these increments, I can go ahead and place my decimals on a number line. So I know that -0.375, that looks like money, and if I ignore my last digit, that would be -37 cents. So -37 cents will be right here on the number line, and that matches the fraction of -3/8. For the other decimal, -0.312, I can go ahead and ignore the last decimal, and that looks like -31 cents. -31 cents would be on the left-hand side of -0.3, and that fraction is -5/16. So just by comparing these two numbers on the number line, I know that -5/16 is larger because it's closer to 0. So I'm going to read my statement as -3/8 is less than -5/16. Or you can write it like this. -5/16 is greater than -3/8. So pause the video, complete the got it problem, and play it back for some feedback. So for example 4, they're asking us to compare two rational numbers, which is -51/100 and -8/15, using the less than symbol, the greater than symbol, or the equal to symbol. One thing that we might want to do is convert our fractions to decimals so that we can figure out how the two decimals are comparing. So I'm going to use -8/15, and I'm going to use the in and out method. So after using in and out, I know that the fraction -8/15 is equal to -0.53 repeating. So I'm going to go ahead and write -0.5 repeating under here. And let's go ahead and graph it on a number line. I know that both rational numbers are between 0 and -1. And I'm going to jump in increments of tenths. So after placing the increments by tenths within my number line, I'm going to go ahead and graph this. I know that -51/100, that looks like -51 cents. That would go on the left-hand side of -0.50. And -53/100 repeating, I know that would go a little further left because it's -53 cents. So that first dot would be -0.51, and our second dot would be -0.53. Repeating. I know that -0.51 is larger because it's closer to 0. So my statement would be negative 0.51 is greater than negative 8 over 5 or 15. Or I can write it like this: negative 8 over 15 is less than negative 0.51. So for example 5, we're going to go ahead and compare two rational numbers. The first rational number is 3 over 7. Our second rational number is 0.413. And what we're going to do is we're going to convert that fraction, 3/7, into a decimal so that we can compare both decimals. So I'm going to write 3 over 7, and I'm going to use the in and out method to convert 3/7 into a decimal. So after using in and out, I got 0.428. This division problem does continue on, but I stopped after 0.428 because the place value of 8 matches up with the place value of the 3. So now I'm going to write 0.428 right underneath the fraction 3/7, and I'm going to use a number line to compare these two. So I know that both numbers are between 0 and 1, so I'm going to zoom in on my number line between 0 and 1. And I'm going to count by increments of 20ths. So after listing my increments of 20ths here, I can go ahead and graph both decimals on the number line. So the first decimal that I'm given is 0.428. And if I look at that as money, I can ignore the last place value, and that looks like 42 cents for me. 42 cents will come after the 40-cent mark. So this region right here would be 3/7. If I look at my second number, I've got 0.413. Now if I look at that as money, I can cross out the last place value. That looks like 41 cents. 41 cents would be closer to the 0.40 mark. So this first mark would be 0.413. I know for a fact that 3/7 is larger because it's farther away from 0. It's on the positive side. So in my statement, I'm going to say 3/7 is greater than 0.41. Or you can write it like this: 0.413 is greater than 3/7. So pause the video, complete the got it problem, and play it back for some feedback. For example 6, we're going to order these three rational numbers from least to greatest, and we're going to use a number line to do that. The first thing we should do is convert all these numbers into decimals. So I can leave negative 2.46 as a decimal already, so I don't really have to do anything to that. But I need to convert negative 2 and 22 over 25 into a decimal. So what we're going to do first is we're going to write negative 22 over 25 here. And let's use the in and out method. So after using in and out, I got the decimal form of 0.88. So I'm going to write it as my whole number as negative 2.88. That is the decimal form of negative 22 over 25. So I'm going to write negative 2.88 right below that. The next thing that we're going to do is we're going to write negative 2 1/10 as a decimal. So I'm going to write negative 2 1/10 right here. And using the in and out method, again, let's convert it to a decimal. So after using the in and out method, I got negative 2 as my whole number and 1/10 as my decimal. So I'm going to write negative 2 1/10 right below my fraction form of negative 2 1/10. So now that I've converted these into decimals, let's go ahead and use a number line and graph these decimals on a number line. I'm going to use the two integers, negative 2 and negative 3, to zoom in on my number line. And the reason why I use negative 2 and negative 3 is because all of my rational numbers up here are all between negative 2 and negative 3. So I'm going to count by tenths on my number line. So here's negative 2 and 1/10. Here's negative 2 and 2/10, and so on. So after completing the increments within negative 2 and negative 3, I can go ahead and graph the rational numbers on the number line. So the first rational number that I'm going to graph is negative 2.46. So negative 2.46 would be about here. So there's negative 2.46. The next rational number that I'm going to graph is negative 2.88, which is the same as negative 2 and 22 over 25. And that would probably be around here someplace. There's negative 2, 22 over 25. It's closer to negative 3. And the last one that I'm going to graph is negative 2 and 1/10, and that's right here. I'm going to write negative 2 and 1/10. So now that I've completed my number line and plot my decimals on it and my fractions on it, I'm going to go ahead and place these in order from least to greatest. I know that the smallest number on here has to be on the left-hand side of the number line because it's furthest from 0. So negative 2 and 22 over 25 is the smallest number because it's farthest away from 0, followed by negative 2.46 is the next largest number, and the largest number of all would be negative 2 and 1/10 because it's closest to 0. So these numbers are in order from least to greatest. So pause the video, complete the got it problem, and then play it back for some feedback. So now that we've completed this lesson, go ahead and self-rate yourself on how you feel about it. If you still don't understand the lesson, please go back and watch the video again, and write down some questions, and bring them to class, and we can talk about them tomorrow.